Okay, so this is going to be a relatively short video. This one is on the algebra of matrices and how it works. So, like I mentioned before, matrices are a rectangular array of numbers. Usually they're written with capital letters. So, for example, we have matrix A here is this matrix there. We would write that as A, and we write a 2 by 3, where 2 is the number of rows and 3 is the number of columns. So it's a 2 by 3 matrix. Any matrix, m by n, with the same number of rows and columns is known as a square matrix. So if I have a matrix that in this case is 3 rows by 3 columns, we call that a square matrix. That also works for a 4 by 4, a 5 by 5, a 20 by 20, however high up you want to go. The identity matrix is a square matrix where the diagonals are all ones and all the other numbers are 0. So this is what's known as the identity matrix, where the diagonal, this main diagonal here, is ones, and every other number you see here is zeros. So, here's a question. How do I add or subtract matrices? So, here's how this works. Let A and B be matrices of the order m by n. So I'm saying I have two matrices that are both the same size. They're both m by n. There's some writing there, but I'm going to talk you through it. It's as simple as you want it to be. The important part is this part right here. Matrices must be the same size in order for you to add or subtract them. They must be the same size. No ifs, ands, or buts about it. They must be the same size. So, to add or subtract them actually works just as nice as you want them to. So, to find A plus B, I have matrix A, which is 2, 4, negative 3, negative 1, 0, 1, and 3, 2, negative 2, and I am adding that to matrix B, which is 5, negative 2, 0, 4, 6, 9, and negative 5, 1, negative 2. To add these matrices together, all you have to do is add the elements that are in the same position. So for example, this is a 3 by 3 matrix, this is a 3 by 3 matrix. My final matrix down here is going to be a 3 by 3 matrix. To figure out what goes here in the top left, I'm just going to take the top left of my first matrix and add it to the top left of my second matrix. 2 plus 5 is 7. Next, 4 plus negative 2 is 2. Negative 3 plus 0 is negative 3. Negative 1 plus 4 is 3. 0 plus 6 is 6. 1 plus 9 is 10. 3 plus negative 5 is negative 2. 2 plus 1 is 3. And negative 2 plus negative 2 is negative 4. This here represents A plus B. That's all that we had to do. To find A minus B, yes, it does work as simple as you want it to. I'm going to have my matrix A, which was 2, 4, negative 3, negative 1, 0, 1, 3, 2, negative 2. And now I'm going to be subtracting that by my matrix B, which is 5, negative 2, 0, 4, 6, 9, negative 5, 1, negative 2. And the only difference between addition and subtraction is I'm going to be subtracting now. So this is still going to create a 3 by 3 matrix. To find what goes in the top left, I'm going to do 2 minus 5. Well, 2 minus 5, that's negative 3. 4 minus negative 2, watch out for double negatives when you're subtracting. This will actually equal positive 6, right? 4 minus negative 2. Negative 3 minus 0, that's just negative 3. Negative 1 minus 4, that's negative 5. 0 minus 6, that's negative 6. 1 minus 9, that's negative 8. 3 minus negative 3, again, watch out for the double negatives, that's going to be a positive 6. 2 minus 1, that's just 1. And negative 2 minus negative 2, watch out for double negatives. This minus negative 2 is going to turn to a positive 2. And then with a negative 2 there, this actually works out to just be 0. But that's how you add and subtract matrices. It works as nice as you'd want it to. For adding, you just add the elements together. Subtracting, you just subtract them. Again, matrices for addition and subtraction must be the same size. Okay? If they are different sizes, you cannot add or subtract them. Period. So, let's say I have matrices A, B, and C. And I'm telling you that they are all the same size. Before we get into this, I'm telling you I have some matrices that are all the same size. Well, there's some properties we have. So one of the properties is, let's say I have matrix A, and I'm adding it to matrix B. So I have matrix A, and I'm adding it to matrix B. Well, that actually just equals the same thing as matrix B plus matrix A. I can add matrices in any order I want, as long as they're the same size. Let's say I have matrix A, and I'm adding it to matrix B. And then after that, I'm going to add matrix C to it. So I'm doing this plus this, and then I'm going to add matrix C to it. Well, I can kind of add in any order I want still. I could do B plus C first, right? Like I could do A plus, and now B plus C first. I could totally do that. No big deal. Another property we have is, let's say I have matrix A, and I'm adding to it some matrix 0. I'm adding a matrix of all zeros to it. Well, that just equals my matrix A. If I take my matrix A and add a matrix of all zeros, that just gives me my matrix A. And last but not least, scalar multiplication. Let's say I had some number, let's call it K, multiplied to matrix A plus B. I have some number, some scalar, we call that's just a number, times matrix A plus B. We are absolutely allowed to distribute the K in to K times A plus K times B. And that's all I wanted to cover with this video. Oh wait, sorry, that's not. Got one more thing. Whoops. Oh no, that's it. I'm thinking of the next one. Okay, so let me know if you have any questions.